You spent $240 on batteries last year, not in one trip, not in one dramatic purchase, but in a slow, invisible bleed across dozens of devices you barely think about. The phone charger, the laptop, the kids' toys that die on Christmas morning, the power bank that was supposed to save you during that blackout but sat there like a brick. Every single one of those purchases fed the same machine, and every time something swelled or faded or just quietly stopped holding a charge, you paid again to get back in. You probably thought that was the cost of energy. You probably thought you were paying for the chemistry inside those cells, for the raw power they deliver. You weren't. You were paying for a system designed to make sure you never stop paying. And then there's the part that should genuinely make you angry. The design philosophy itself is built against you. Sealed packs you can't open, smart chips that refuse to work with third-party chargers, planned obsolescence baked into firmware updates. These aren't engineering necessities. They're business decisions. They exist to make sure that when your drill battery dies 18 months from now, your only option is to buy another $60 cartridge from the same company. The entire architecture of modern batteries is optimized not for your benefit, but for repeat extraction from your wallet. Now picture this, a soda can, table salt dissolved in water, a scrap of carbon. That's it. That's a working battery. About $2 in materials, most of which you already threw in the recycling bin this week. Aluminum and salt water can produce real usable electricity, enough to run an LED, enough to power a small radio, enough to charge a device in an emergency. No app, no subscription, no planned death date, no $60 replacement cartridge, just chemistry so simple. A teenager can build it on a kitchen counter in 15 minutes. You've never seen this in a commercial. You've never seen it on a shelf at the hardware store, and that silence should tell you everything. Because when a technology has no lobbyists, no commercials, and almost no space on shelves, the question isn't whether it works. The question is who loses money if you find out it does. So what does that kind of chemistry look like in real life? Here's the math nobody puts on the packaging. $240 a year divided across maybe 60 individual battery purchases. If you count every AA swap, every replacement power bank, every cordless tool pack that quietly dies 18 months in, that works out to $4 per transaction on average, and most of those transactions buy you chemistry that costs pennies to manufacture. You're not paying for energy. You're paying for the plastic shell, the brand name, the shelf space rental at the hardware store, and the silent agreement that you'll be back in 8 weeks when the next one gives out. Now flip the ledger. One aluminum air cell costs roughly $2 in raw materials. Scrap aluminum table, salt dissolved in water, a piece of graphite you can pull from a dead pencil or a carbon rod salvaged from a landfill-bound zinc battery. That single cell lights an LED, stack 4 of them in series, and you cross the voltage threshold to trickle feed a USB power bank through a boost converter that costs less than a cup of gas station coffee. Run the numbers cold. If each cell gives you even a few hours of low draw power before the aluminum plate corrodes through, and you can rebuild it in minutes from materials that were headed for the recycling bin anyway, your effective cost per watt hour drops to a fraction of what any retail battery delivers. Not half, not a third. A fraction so small it makes the entire pricing model of sealed consumer cells look like a protection racket. And this isn't garage speculation dressed up as science. Aluminum air chemistry has been documented in peer-reviewed journals since the 1960s. National laboratories built working prototypes. Military contractors tested it as a long-duration field power source because the energy density of aluminum, pound for pound, embarrasses lithium. Universities published papers showing aluminum air range extenders could push electric vehicles hundreds of extra miles on swappable metal plates instead of pumping gasoline. The chemistry is not fringe. It is not theoretical. It is so well understood that the only honest question left is why you've never seen it on a shelf next to Duracell. Think about what that means for your $240 annual habit. You're buying sealed black boxes made from cobalt mined by hand in the Congo, lithium extracted from water tables in Chile, nickel processed through emissions, heavy smelters, all refined and shipped across oceans and marked up at every waypoint. When the third most abundant element in the Earth's crust is sitting in your recycling bin right now, already shaped into thin sheets, already waiting to oxidize and hand you electrons for almost nothing. The raw aluminum in a single crushed soda can holds more electrochemical potential than the AA battery you paid $4 for last Tuesday. You threw the can away and bought the battery. That's not ignorance. That's the result of a market that has zero incentive to tell you the cheaper option exists. So the chemistry is real, the cost difference is grotesque, and the documentation stretches back decades, which raises an uncomfortable follow-up. If aluminum air cells work this well on paper and in labs, if they powered prototype vehicles and military hardware, something very specific must have kept them off the consumer market. And that something has nothing to do with physics. Here's the part that should make you uncomfortable. You already own the raw material. It's sitting in your recycling bin right now, or crumpled on your passenger seat, or stacked in a bag you'll drag to the curb on Thursday. Every soda can you've ever crushed and tossed was a tiny aluminum fuel cell waiting to happen. Not metaphorically, chemically. The industry doesn't charge you $240 a year because the atoms are rare. They charge you because you never learned what those atoms can do when they touch salt water and air. That's the real stratification, not effort versus laziness, not smart versus dumb. It's people who understand what they already possess versus people who keep buying back their own potential in a blister pack. So let's make this concrete. A rectangle of aluminum scraped clean until it shines. A plastic container you'd otherwise throw away. A tablespoon of table salt dissolved in tap water. A piece of paper towel folded around crushed charcoal from your cold grill. 2 wires. That's the entire bill of materials for a functioning electrochemical cell. The aluminum gives up electrons. The carbon cathode, breathing open air, accepts them. Salt water carries the charge between. No proprietary electrolyte, no rare earth metals mined by children on another continent, no firmware update that conveniently throttles your capacity after 18 months. You press the aluminum against one wall of the container, shiny side inward. You set your little carbon pillow opposite it, cloth keeping them from touching, top edge exposed so oxygen can reach the reaction surface. You pour in the salt water until everything's soaked. And one wire clips to the aluminum, that's negative. The other clips to the carbon or graphite rod tucked inside the pillow, that's positive. And when you touch a multimeter to those leads, you'll see roughly 1 volt staring back at you. Connect a low-power LED and it glows. Light pulled from garbage in under 20 minutes. Now sit with that for a second. The thing glowing on your desk cost you functionally nothing. The aluminum was destined for a landfill. The salt came from a container that costs less than $1 and holds enough for hundreds of cells. The charcoal was left over from last summer. Every component was already in your possession. You didn't need to drive anywhere, subscribe to anything, or wait for a delivery drone. The only thing that was missing was the knowledge of how these ordinary objects relate to each other. And that missing knowledge is precisely where the margin lives. Not in the lithium, not in the cobalt, not in the engineering, in your ignorance of what you already hold. That's the layer most people never see. The battery industry isn't selling you stored energy so much as selling you the belief that energy storage is beyond your capability. The complexity is the product. The sealed casing, the warning labels, the recycling guilt, the planned obsolescence, all of it exists to maintain a wall between you and a chemical reaction, simple enough to demonstrate with kitchen scraps. You are being charged a premium to not understand your own trash, and once a single cell lights up on your workbench, that wall develops a crack. The question becomes how wide you can break it open. So now you know the crack exists. You know the math tilts in your favor. But knowing and doing live on different planets, and most people die on the knowing side because they wait for the perfect moment to build some elaborate off-grid power station in their garage. Forget that. Here's the smallest possible move you can make tonight, and it is so boring it almost feels insulting. Go to your kitchen, pull 1 aluminum can out of the recycling. Not 2, not 6. 1. Set it on your counter next to a tablespoon of salt and a glass of tap water. That is your entire commitment. You're not building anything yet. You're not wiring cells in series or hunting for carbon cloth online. You are placing 3 objects on a surface where you will see them tomorrow morning. That is the action. That is the whole thing. Why something this pathetically small? Because the real enemy here is not ignorance. You already have the information. The real enemy is the invisible loop that fires every time a device dies. Battery dead, grab keys, drive to the store, scan the aisle, pay $4 for a glossy pack, toss the dead ones in a drawer, repeat. That loop has been running in your household for years, maybe decades, and it has a physical trigger. The trigger is the moment you reach for your wallet instead of reaching for raw material. 1 can on the counter interrupts that trigger. It sits there like a question mark. It forces a 2-second pause the next time your flashlight flickers. And a 2-second pause is all it takes to break a spending reflex that has been costing you quietly month after month, year after year. Now here's where it gets mechanical. Once that can has been sitting there for a day or 2 and you have not thrown it back in the bin, you do one more thing. You cut the can open with kitchen scissors, flatten it into a rough rectangle. That is your anode. You do not need to sand it, polish it, or measure it with calipers. Rough aluminum, salt water, and a breathing surface for oxygen. That is the entire chemistry. You already own every component. The salt is in your cabinet. The water comes from your tap. The only piece you might not have lying around is a small square of activated carbon fabric, and even that can be replaced with a chunk of charcoal from a dead campfire or a piece of carbon rod pulled from inside a spent D cell you were about to throw away anyway. The point is not to power your house tomorrow. The point is to hold a working electrochemical cell in your hand for the first time and watch a small LED glow from garbage. That single moment rewires something in your brain. It makes the sealed blister pack on the store shelf look like what it actually is, a markup delivery vehicle dressed in shiny packaging. Once you have seen voltage come out of a soda can, you cannot unsee it. The mystique evaporates. And when mystique evaporates, so does your willingness to keep paying a premium for something you can assemble from scraps on a Tuesday night. Do not scale up yet. Do not order boost converters. Do not start sketching a 12-cell series pack on graph paper. That impulse to leap ahead is exactly what kills execution for most people. They skip the boring foundation, get overwhelmed by the build, and default right back to the store aisle within a week. One can, one cut, one cell, one LED. Prove the chemistry works with your own hands, on your own counter, with materials that cost you literally nothing because they were headed for the trash. That is your only job this week. Everything after that, the series wiring, the USB trickle charging, the emergency kit assembly, all of it becomes inevitable once the first cell lights up. But none of it matters if you never place that single can on the counter tonight. And once you have done it, once you are holding a live cell made from refuse and salt, something else becomes obvious. The design can get simpler, more transparent, more immediate than even this first build suggests. Here's the part where most channels would tell you this changes everything overnight, that you'll never buy a battery again, that the industry is shaking in its boots because you watched a video. I'm not going to do that, because the honest truth looks more like this. You built a cell, you got a voltage reading, you lit something small in a dark room, and then you sat there realizing the gap between the tiny glow and the seamless power you're used to is still enormous. That gap is real. Respect it. This isn't a replacement for your lithium pack tomorrow morning. It's not going to charge your phone while you sleep or keep your fridge alive through a 3-day outage on its own. What it does is something quieter and, over time, far more dangerous to the people selling you sealed black boxes at markup. It gives you an exit door you can walk through whenever you choose. Think about what that actually means in your body, in your daily life. Next time, the power blinks off at 2 in the morning and your kid is scared and your phone is at 9%. You're not the person pacing in the dark, wondering how long until the grid comes back. You're the person who reaches into a pouch, drops a strip of scrap aluminum into salt water, clips 2 wires, and has enough light to read a book or enough juice to pull in an AM radio signal telling you what's happening outside. That's not wealth. That's not disruption. That's just a buffer between you and total dependence, a tiny cushion of breathing room that costs you almost nothing to maintain. And here's where the compounding starts, not in dollars, but in knowledge. Every time you swap a different metal into that cell, every time you test rainwater against tap water, every time you notice the cathode clogging and figure out how to clean it, you're building something no corporation can repossess. You're stacking understanding. The first build teaches you electrochemistry is real and accessible. The second build teaches you variables. The third build teaches you failure modes. By the 10th, you're not following instructions anymore. You're designing. That curve doesn't flatten, it steepens, and it costs you the price of a soda can and 20 minutes of curiosity each time. I want to be blunt about what I'm not promising. I'm not promising you'll go off-grid. I'm not promising you'll save thousands of dollars. I'm not promising this replaces professional engineering or industrial-scale storage. If someone tells you a single DIY chemistry will do all of that, they're selling you the same fantasy the battery aisle sells you, just in a different wrapper. What I am promising is this. You now own a piece of knowledge that cannot be taken back. You know that energy is not a mystery locked behind patents and price tags. You know the chemistry is simple enough to hold in your hands. And you know that the next time the system fails you, whether that's a blackout, a price hike, or just the slow bleed of buying disposable cells every month like groceries, you have at least one option that doesn't require anyone's permission. That's your exit, right? Use it or don't. Build 1 cell or build 50. Share it or keep it quiet. But from this moment forward, you're no longer someone who only rents energy from a shelf.